Hi, this is Marwa, and today we have a new video where we are going to discuss quadratic functions. Now, we had a video about functions in general where we discussed how the graphs of functions will look like. We discussed the meaning of domain and range. Then we made another video where we discussed the translation or shifting of functions. How will it look like in an equation and how will that affect the graph? Today we're going to have a new video where we will only focus on quadratic functions, but through quadratic functions we will learn how does functions stretch, compress, or reflect. So we are going to use quadratic functions to explain the different types of transformation that we have not explained before. We will also see what's the meaning of vertex form of a quadratic function and how we can use that vertex form to sketch a graph of a quadratic function. Sketching the graph doesn't mean necessarily graph it accurately, but it means being able to imagine how the graph would look like and make a rough draft for it. In case you are taking the SATs, then you can recognize the graph once you see it. So let's see what we have. Now, at the beginning, I just want to explain to you why does the quadratic function look like a parabola? Like here we are supposed to graph the function y equal x squared, and I already wrote the graph for you. So this is the graph of the function y equal x squared. But what we're going to discuss is why does the graph look like that? And what is so significant about this graph? Well, it's pretty simple. If we take that this is the values of x and these are the values of y, and we start substituting, let's say for x equal -2, then y is going to be -2 squared, which is 4. So your first point on the graph is going to be at x equal -2 and y equal 4, and this would be your first point. Then when you substitute for -1, for example, then -1 squared is going to be 1. So at -1 here, y will be equal to 1, and this is your second point in the graph. When it's 0, then I have 0 squared, which is 0. So you have a point here at 0 and 0. Then if I choose 1, then 1 squared is 1. So at 1, x equal 1, y is also equal to 1. Just take in consideration here that there are two values of y equals to 1 corresponding to two different values of x. So if the input is 1, your output is 1, and if the input is -1, your output is also 1. If I take 2, and I'll stop at 2 here, as a value of x, then the value of y is going to be 4. So at 2 here, x equal 2, y equals 4. Now, why did I do this? I want you to see the following. Of course, if we continue like 3, 4, 5, the graph will continue to extend towards infinity. Now, why do I want you to see this? Multiple things. First of all, there is a symmetry in the parabola. Like, what do I mean by symmetry? If you look at this line here, the y-axis, you will find that the right side of the y-axis is a reflection of the left side, right? So there is symmetry in the parabola. So this line here, and in this case, this line is x equal to 0, is what we call axis of symmetry. So the parabola has an axis of symmetry, and in this case, it is the line x equals 0. One more thing, a parabola has a vertex. This point here is the vertex of the parabola. Okay, so the vertex in this case is 0 and 0. This is what we call the vertex of the parabola. So the parabola has a vertex, and in this case it's 0 and 0. It has axis of symmetry, and in this case it's the straight line x equal to 0. Okay, it is symmetric. So if I only have the value of output when x is equal to 1, I can just draw a line on the axis of symmetry and plot the other point. I don't have to do all this. I did it just to explain to you how the parabola looks like. But I will show you in a minute how you can graph a parabola without making a table, just from knowing where the vertex is, where the axis of symmetry is, and maybe 1 or 2 points. Now, this parabola is the parabola for the parent function, which is y equal x squared. Now, we said before that the parent function is the simplest form of the function. There is another form that we use usually, which is called the vertex form. Now, the vertex form of a parabola is going to be f of x equals a, and a is a value multiplied by x minus h squared plus k. Now, we did discuss before that this h that is associated with x shows you the horizontal shift. And this k outside, the number outside, shows you the vertical shift. What we did not discuss before is what does the value of a mean. Now let me show you using the graphing utility Desmus what it means. Now if you look here, this function here, this is the graphing utility Desmus. I will give you, it's free online and you can all use it, and it's very helpful to understand how graphs behave. I will write for you the link for this in the description and make sure you use it. Now this is the parabola y equals x squared. Now if I have a value of a, and as you can see here y equals a to the power of ax to the power of 2. Now if a is equal to 1, this is how it looks like. Now what if a is more than 1? Like let's say that the parabola is y equal 2x squared. Well, what happens? Look at that blue. If it's 3, well, what happened to it? It stretched vertically or it became narrower. If it's 2, it will become wider. If it's 1, you will go back to the normal parabola we have. What if it's less than 1? Well, if it's half, what happened to it? Or 0.3, it compressed. It compressed vertically, like as if you are pushing it down, so it became wider. We're looking at the blue graph. The red graph here, this red parabola is y equal x squared. The blue one is the one that we are trying to apply with the value of a. So if a is less than 1, as we can see here, wait a minute for the negative, but if the a is less than 1, between 0 and 1, the graph will become wider. If it is more than 1, it will become narrower. When it becomes narrower, we say it's stretched. It's stretched vertically. When it becomes wider, we say it's compressed. Compressed vertically. Okay? Now, what if the value of a is negative? Like if I have negative half x or just negative x squared. What happened to the graph? As you can see, it went down. Like all the values of y became negative. So what happened here is a reflection, as you can see, because we have a equal negative 1. So this is the function y equal negative 1 x squared. And if that negative is greater than 1, as you can see, it will be also stretched vertically. It will look narrower than the original graph or the parent function. If it is like half, what happens to it? It becomes wider. Okay? Now, if it's not negative at all, if it's positive again, between 1 and 0, it's wider or compressed. If it is more than 1, it is stretched. Now, we have seen how a affects the graph. Let's go back to what we were doing here. Now, we have here 3 different options where you can see. We said that this is f of x equal a x minus h all squared. Now, in all of these 3, the values of h and k equals to 0. There's no shifting whatsoever. We're only discussing what will the value of a do. So now we're only discussing a. Now, this red one here, like we saw a minute ago, this red one here is the function y equal x squared, while this blue one is y equal 2x squared. So the value of a here, I have a x squared. The value of a here is equal to 2. The absolute value of 2 is greater than 1. So if the number is greater than 1, what happens? Stretching. Stretching vertically, like in this direction, it's stretched. Why would that happen? Well, it's obvious, because when x is equal to 1, 1 squared is going to be 1. Then when you multiply by 2, it becomes 2. So instead of having the point, when you substitute here for 1 squared, you'll get 1, right? So on this graph, you'll get the point 1 and 1. While on this graph, if I substitute for x equals 1 squared, then I multiply by 2, your answer will be 2. So when x is equal to 1, again, what happened to y? It's equal to 2. So the graph has stretched vertically. Okay? when value of A is greater than 1. The absolute value, because we do not bother if it's negative or positive when we are talking about stretching and compression. Even if it's negative, like if it's -3, then its absolute value is 3, which is greater than 1, so it still shows stretching. Okay? Negative sign only shows reflection. But the number after the negative sign, which expresses the absolute value, is what shows stretching or compression. If it's greater than 1, that's a stretch. If it's less than 1, like here, I have this green graph is y equal half x squared. So if it's less than 1, what happens? It becomes wider, or it's compressed vertically, as if someone is pushing it down. How do I see that? Well, when x is equal to 1 here, if I substitute in this equation, we said 1 squared equal 1. So here it's going to be at 1 and 1. But if I substitute in this equation, well, 1 squared is 1. When you multiply it by half, you get half. So at 1 and half, this is the point. So what happened to the graph? It's compressed, or it became wider. Now, what happens if a is equal to -1? So this is y equals -1 multiplied by x squared. So a here is -1. If a is negative, if it's less than 0, it shows reflection. In this case, it's -1, so the parabola is only reflected over the x-axis. When I had 1, again, I'll just show you to compare. When I had here 1, again, square is equal to 1, so this was the point. When I had here -1, let me substitute somewhere else. When we have when we have 1 squared, then multiplied by negative, it's -1. So the point here is going to be 1 and -1. Actually, we wrote over it. We shouldn't have. Sorry about that. So here it is. Okay? So what happened is a reflection over the x-axis. Okay? So what do I want you to understand from this? H represents, as we said in the last video, and if you haven't seen it, you have to go back to it and think about it. H is always associated with x. It represents a horizontal shift. I'm moving to the right or I'm moving to the left. K represents a vertical shift. I'm moving up or moving down. While A represents 3 things. If it's negative, it shows reflection. If the absolute value is greater than 1, it shows stretching. If the absolute value is less than 1, it shows compression. Now, we are going to use the information we have just learned to answer the following question. It says here, for each of the following, now we only have here 1, but we have more in the next page. For each of the following, describe the transformation. So we want to describe how this transformed from the parent function. The parent function is y equals x squared, or f of x equals x squared. So I want to know, this was the parent function, and it became this. So what type of transformation happened? Okay, we want to identify the axis of symmetry. We want to identify the maximum and the minimum values, the domain and the range. Now let's just go back for a minute and discuss the maximum and minimum values. Now we have here 2 parabolas, if you can see here. This one is y equal x squared, and this one is y equal -x squared. When we say y equal x squared, the vertex here, as you can see, this is the least value of y. All the values of y are greater than that, right? So we call this a minimum point, because the value of y at the vertex is the least value of y for the whole parabola. So we call this a minimum point. While in the blue graph here, the value of y at the vertex is the highest value of y of all the rest of the points on the parabola. The rest are all negative. So we call this a maximum point. So if your parabola is looking upwards and the vertex is the minimum point, then we call it a minimum. And if the parabola is opening downwards like that, then the vertex is a maximum. Okay? Now let's go back to what we were discussing here. Now, can we describe the transformation and identify the axis of symmetry, the vertex, the domain and range? We absolutely can. Now this is y equals ax minus h squared plus k, right? This is the vertex form of a parabola. Now I know that a is equal to -2. So what does that show me? It shows me 2 things. Because it's negative, then I know there is a reflection, right? So I can, in my description, say that this graph is reflected. Well, if this graph is reflected, it means it opens downwards, then it has a maximum value, right? The maximum value is at the vertex. Okay? Now, what else can I tell from A? Now, if the absolute value of A, the absolute value of -2 is greater than 1 because it's equal to 2. So what does it show? It shows that this function has stretched, right? So I know it's reflected, I know it's stretched than the parent function. I know it has a maximum value. Now, the maximum value is at the vertex. What is the vertex? The vertex of a parabola is h and k. H and k, what are the values of h and k here? Well, h is, if this is negative and this is positive, then h is -1, right? So, because if I substitute here with -1, negative becomes positive. So always whatever is inside is opposite to the sign, and as we said, this is why it moves in the opposite direction. Again, go back to the video of shifting to understand that. Now k is equal to -2. So this parabola has moved to the left 1 unit and down 2 units. So the vertex of the parabola is at -1 and -2. So here we have discussed what's the meaning of vertex form. Well, this is the vertex form. Why do we call it vertex form? Because looking at it, we can't tell what the vertex is. What else does it help me with? It helps me to understand what happened to the parabola. I can say that this parabola has a vertex at -1 and -2. I can say that this parabola is shifted. How many units? 1 unit. Which direction? Left, because h is equal to -1. And also 2 units. Which direction? Down. Okay, because k is equal to -2. So I have described the transformation. What happened in the transformation? Well, this function is reflected, it's stretched, its vertex is at -1 and -2, it shows a maximum value, and it has moved 1 unit left and 2 units down. This is everything we can say about the transformation of the function. Now, what about the axis of symmetry? Well, axis of symmetry is x equal h all the time. Okay? So this is, consider this to be a rule, like one of the rules, that the axis of symmetry is x equal h. Another rule is that the vertex is h and k. Okay? So axis of symmetry is x equal h. So the axis of symmetry is at x equal -1, which we have found a minute ago. So we are done with the description. We identified the axis of symmetry. We know it is a maximum. Now we need to discuss the domain and range. If you remember, we did discuss domain and range before, and we said that the domain of all quadratic functions is from -∞ to infinity, or all real numbers. And nothing will affect -∞ to infinity. So if it's shifted right, shifted left, that won't make any difference. The domain is the same. What about the range? Well, we said that this function is reflected. So we said like it's looking downwards, right? And we said also that this function has an axis at x equal -1, right? We also said that this vertex is at -1 and -2, and we said that this vertex here is the maximum point, which means that the rest of the values of the range are below this line, right? So -2 here, the value of y, remember, we also, whenever we talk about the range, we're talking about values of y. We discussed that in our first video of this series. So I can tell without a doubt that this function, its maximum value is -2. Its least value is -∞. So I can say that the range is from -∞ until -2. Or that the range, because it's reflected, is from -∞ until k. And if it's not reflected, it's going to be from k to infinity. So h and k help me to find the vertex. They help me to find the axis of symmetry. They help me to identify the range. Now I have the graph here, so let's just look at it. Does it look a little similar to what we had? Yes, it does. This is an accurate graph of the function. And if you go to utility, in graphing utility, and just plug in, the equation of the function, you will see the graph. Yes, the vertex is at the point -1, -2. Yes, the axis of symmetry is at x equal -1. Yes, the function has a maximum point. Yes, the range is going to be from -infinity to infinity. Okay? Now that we have seen all this, let's see if we can describe other functions. Well, we have here a lot of other functions that we don't have the graphs for. We just have the values of a, h, and k. We said that this is y equal a x minus h, and I want you to memorize that, plus k. So I can tell that a is -1, right? A is here outside of the function. If I have only a negative sign, I know it's -1. If I don't have anything, then it's 1. Okay, I know that h is equal to, both are negative, so it's equal to 1. I know that k is equal to 4. I will use these to find everything. Now, what can I say about this? I can say that the function is reflected, for sure. Okay, is it stretched? No, the absolute value of -1 is not greater than 1 or less than 1. It's equal to 1, so it does not show any kind of stretching or compression. So it's just reflected. I know that the vertex is at the points 1 and 4. Now, it's reflected, so I know that the vertex is a maximum value. Okay? Because it's reflected. If it wasn't reflected, it would have been a minimum value. Okay? What else do I know? I know that it's shifted. How much? 1 unit, right? And 4 units up. So I know that too. 4 units up because k is equal to 4, and 1 unit right because h is equal to 1. What about the domain? Domain is always -infinity to infinity for all quadratic functions and all polynomial functions, not only quadratic, and we will discuss polynomial functions later. What about the range? I know it's reflected, so it's from -infinity until k, which is 4. Okay, what about axis of symmetry? Well, as we said, axis of symmetry is always x equal to h, which is 1. If I want to sketch it, easy. At 1, I'll make an axis of symmetry. At 4, here, at the point 1 and 4, I know this is my vertex, and the parabola is inverted, and it would look like that. You can double check by using the graphing utility Desmus. What about this function? I'm not going to do them all. I'm going to do this one, then you do the last one. A is equal to 2, so there is no reflection because it's positive. It's only stretch, a vertical stretch, right? What else? I know this is A, I know this is H, I know this is K. Well, H is equal to 2 also, because in the vertex form is negative and this is negative, so no need to change the sign. While if this one is positive, then we're going to change it, it's going to be -7. K is equal to 5, so I know that the vertex is at 2 and 5. Okay, if it's not reflected, so I know that this vertex is a minimum. The whole graph will be looking upwards. Okay, so this is a minimum value. What else do I know? Is there any shift? Yes, shifted. How much? 2 units to the right and 5 units up. Okay, so I know it's shifted to the right 2 units and up 5 units. What about the domain? Well, again, -infinity to infinity, that does not change. What about the range? Well, let's look at it here. It's not reflected, it's looking upwards, so the range will start from k, which is 5, until infinity. So if it's reflected, from -infinity until k. If it's not reflected, then from k until infinity. What about axis of symmetry? That does not change, it's at x equal h, which is 2. If I want to just make a sketch for this parabola at 2 here, this is going to be my axis of symmetry at 5. So this is going to be the vertex. It looks upwards like that. This is 2 and 5. And this is like a sketch for the parabola. Now, a sketch for a parabola is not an accurate graph. And if you're solving the SATs, you don't need an accurate graph. You need a sketch, okay? If it happens that you see more than one graph that have the same axis of symmetry and the same vertex, then try to substitute for one of the points, like substitute for x equal 1 or for x equal 2, and check if that point is on the graph or not. Okay, now this last one you will do and write for me the answer in the comments. What we will see in the future is that the same way the parabola has been transformed, like how the value of a has affected its stretching or compression or reflection, is the exact same way for other types of functions. Like if I'm talking about absolute value function, or if I'm talking about square root function, it has the value of a has the same impact on the function. It shows reflection, stretching, or compression. Okay, we will see that later. Now, throughout this video, we have understood how the graph of a quadratic function looks like, how it would shift, how it would reflect, if it's compressed or if it's stretched, and how does that affect the range of the function, because as we said, the domain of the quadratic function does not be affected ever, because it is all real numbers or from negative infinity to infinity. I hope you found this useful. In our next video, we will discuss quadratic functions again, but we will not discuss the vertex form. We will talk about the standard form. Thank you so much for watching.